Welcome students to the series of lectures on LangGraph, and in this series of lectures on LangGraph, we are going to do the actual implementation of a multi-agent system where in LangGraph. See, in the last session, what we did, we moved away from the reflection agent. In the reflection agent, we were using a single large language model, and then we decided to create a LangGraph workflow where we would use different agents to perform different tasks, different activities, and take different responsibility. So what was the workflow? So this is our basic workflow: user question, research agent, writer agent, critique agent. Then there is a decision function, there is an improve agent, and a critique agent, right? So a user asks a question. So a user asks a question. There would be a research agent. From this research agent, we will leverage Grok, large language model, and will create a research agent. But when we want that output of the research agent to be summarized properly, I will use a different large language model in a form of a writer agent. For that, I'm using a Gemini large language model, basically Gemini large language model. Then to evaluate, I will use critique agent or evaluation agent, which behaves like a subject matter expert where in evaluation or being a critique. And I will be using Ollama or Llama. This agent will perform certain tasks. What it will do, it will evaluate the answer. It will provide you the feedback. It will provide a score between 1 to 10. And if the answer is good, perfect, I will respond to the user and it will end. If not, then I ask my improve agent, which again I can create using any other large language model. Here I'm using Gemini. You can use any other large language model. And after that improvement, the critique agent evaluates again. Once the score is greater than, say, equal to or greater than equal to 8, say any number, 7 or 8, will return the final answer to the user, or it will keep on going in the loop till it gets the answer which has a satisfactory score. And what we'll do today, we'll implement this in our Jupyter Notebook. Perfect. So what is the step one? See, the step one, which is like the basic step to implement any large language model or to invoke any large language model, is to fetch your API keys for those large language model. So what API keys will try to fetch? We'll try to fetch the API keys for all the models that we are using. We are using Grok and Google Gemini. So we'll try to fetch the API keys. First of all, I'll go to Grok and I'll create my API keys. The API keys would be LLM, LangGraph, multi-agent. You can write any name. I will submit it and I'll copy my API key. Remember that you have to copy it, otherwise it will not be displayed again. Now this was Grok API key. Now I need my Gemini API key. Again, I'll go to my AI Studio for Google. I'll create my API key. Again, I'll use LLM multi-agent in LangGraph. I'll create the key. So this is my key. I'll copy my API key. I'll paste my API key. Okay. So these are my API key. I'm storing it in a variable, which is your Grok API key, your Google API key. Perfect. Step two. What is step two? Step two is to import required libraries. So this is the important step, to import your requisite or required library. So from typing, import TypedDict. From LangGraph.graph, import stategraph start and end. From LangChain underscore Grok, import chatgrok. This is a class. From LangChain underscore Google underscore Gen AI, import chat Google generative AI. From LangChain underscore community dot chat underscore models, import Llama. Now, please, I'm reiterating, typedict is used to define the state. Typedict is the special Python class that creates a dictionary with what? With predefined data type. So our state will have what? have fixed keys, and have fixed data type, a perfect dictionary. State graph. What is state graph? State graph is the main critical class in LangGraph that you use to define nodes, define ages, build and compile your workflow, right? Otherwise, you won't be able to execute your graph. So state graph help us to define and build the entire workflow. What are start and end? Start and ends are special markers. Start helps to identify the entry point in the workflow and end the exit point. End defines the exit point. What else? These are the LLM providers. Sorry, except this one. These all are LLM providers. So we are using Chat Grok for Grok large language model, Chat Google generative AI for Gemini, Chat Ollama for Ollama or Llama. Please understand, we are using LangChain wrappers. LangChain wrappers because LangGraph works with runnable interface and LangChain models are already runnable compatible. LangGraph works with runnable interface and LangChain models are already runnable compatible. So LangGraph integrates very smoothly with LangChain. So you don't have to create any other class in LangGraph to import or create a pipeline with a large language model. Now what we'll do, I'll create my agents. So here I'm creating my agents. This has nothing to do with LangGraph. I'm just creating my agent. Okay, so first I'll create my research agent. What I'm using chat group class. I create an object which is research underscore LLM, research underscore LLM. And for that, I'm using the class chat group. What I'm providing model name and API keys as parameters. This creates my research agent. This agent will perform what? The research or knowledge generation. Then what I'll create? I will create a writer agent. Writer agent, I'm using what? Gemini, or I'm using the class which is chat Google generative AI. Again, I'm passing what? Model API keys, model API keys. And see here it is API underscore key. Here it is Google underscore API underscore key. Perfect. So please remember the keys for the keys are different for different models or different classes of the models. Okay. This creates my writer agent. This agent will perform what task? It will first format the output from the research agent. It will summarize. It will improve the readability, right? That would be the task of the writer agent. Then we have what? Critique agent. I'll create a critique agent. So let me run this. So this is my research. This is my writer. Now I'm creating a critique agent. For critique agent, see, you can see there is a problem that is occurring for Ollama. So I'll create a backup critique agent also. So sometimes the large language model Llama doesn't perform as expected. So I'm creating my backup critique agent with the help of Gemini large language model. But what is the responsibility of the critique agent? The critique agent will evaluate answer, give feedback, and what? Provide you the scope. And please remember, I'm creating a backup critique agent. You can directly use Ollama. In Ollama, you don't have to fetch the API keys. You can directly use Ollama or Llama large language model. Perfect. Now, there is another reason why I'm creating the backup agent because Ollama or Llama is a local model, a smaller model. So the reasoning capability may be limited. So I'm using Gemini. You can use any other model. You can use OpenAI. It is up to you. Okay. Now, what else? I'm defining my state. I'm defining my state. Okay, sorry, I didn't run my import function. I'm defining my state. So instead of dictionary, I create agent state. I'm creating what? Agent state. I have inherited TypedDict. So this dictionary will have question as a string, research as a string, answer as a string, feedback as a string, and integer as a string. This is the dictionary which was created with the help of TypedDict class. This create a very structured state. Now I define my research agent. This is my research agent node. I'm defining my node. I'm defining my node. So I'm defining my research agent node. I pass the state. You can see I'm passing the state. The name of the state is agent state. I just defined it. Then please understand from the state, I am fetching the question which is being asked. But then I'm using invoke invoke, please understand, invoke is a part of runnable interface, which is used in LangChain and also in LangGraph. We discussed about this thoroughly in the previous session. Okay, so what it is doing, this special function is actually invoking your large language model, where I invoke the research large language model, which was a Grok large language model. This is a writer agent. Again, in the writer agent, I will pass my state, which is agent state class. Again, I'm taking what? I'm taking the response which got stored in the research of what? Research of the state. Okay, I got my response from the previous research agent. I'm storing it in research variable. Then I'm invoking what I'm doing. I'm invoking again using what? Invoke function with the help of what? With the help of LangChain. With the help of LangChain. And this is a writer large language model. This is a writer large language model which is being defined with the help of Gemini. What it will do? It will format the research output. Then what I have to do? I have to create my critique agent node, not critique agent node. I already created my critique agent. I've defined my critique agent. I have to define my critique agent node. Now what this node will do? This node will evaluate the answer, give the feedback, and give the score between 1 to 10. So it will evaluate the answer, give the feedback, and score between 1 to 10. How it will perform? It will take the answer from the state and it will provide that answer as a parameter in this invoke. Right? We discussed about this invoke. Perfect. What next? We have to create an improve agent. Again, I have to use invoke. So I'm invoking a large language model. A large language model. What it will do? It will take the answer. It will take the answer. It will take the feedback from where? From the state which you're passing in your improve agent. And it will pass in the invoke. We'll say that improve the answer. This is the answer and this is the feedback. Please improve it. Then it will get a response. It will store the response in the answer and it will also store the iteration that how many times you have improved. Perfect. Now there would be a decision function. There would be a decision function. Decision function is like if the score is greater than say 7 or 8. If the score is greater than equal to 8, return end. Otherwise, check if the iteration is greater than 3, 4 or 2. Return end. Else go and improve. So that is what is happening here. If 8 is in feedback, 9 in feedback or 10 in feedback, then return the answer or improve or improve. If the feedback is 7, improve. If the iteration is less than 2, improve. If the return is equal to greater than 2, then end. Give the answer as it is. So if any one of the condition got satisfied, then this decision function will provide you the final answer. What we are doing here, we all know what we are doing here. We are creating the graph. Graph is equal to state graph. What is state graph? State graph is a special kind of class. It understands the workflow, the nodes and edges. What I'm passing, again, I'm passing the state. What I'm building the workflow graph with the help of state graph class. Once it is created, then I'll add the nodes in this object. So graph dot add nodes. Then I'll add my edges. This is like as it is we discussed in the basic sessions of LangGraph, and then I'll compile it, right? Then I'll compile it because if I don't compile, then the graph will not understand the nodes, the edges. Compile converts the graph definition into executable workflow. And without compile, the graph is defined, but you cannot execute it. So it is the most important step. You need to compile your graph and you're storing it in workflow. Now, if you want to check whether your graph has been compiled as you expected, your workflow has been defined as expected, if your graph has been compiled as expected, if the workflow has been defined as expected, you run this cell. We discussed about this cell in a complete session. So let's see. Okay, so user will give the input. then the research agent will get invoked, then the writer, then the critique. Critique will give the final answer if the score is greater than 8. If not, then it will keep on improving till the iteration is greater than 2, 3, or 4. So it is a correct implementation of my workflow. Now, what I'll do, I'll ask the question. So I'm providing two values to my keys of the state. Question: explain quantum computing. What is the iteration? Because I have just started, so I'll provide the iteration as 0. But understand, I'm not providing any information for what? For the research, for the answer, for the feedback. It's the responsibility of the agent to fill these. So let's see. It will take some time because the workflow is invoking, initializing, connecting the pipeline with large language model. Okay, so it will take some time. Let's wait for a few seconds. So we can see that we got the output of result. Let's print the result. This is the complete output of result, and let's have a look at how many iteration it ran. You can see it is giving the result in the first iteration. It means the workflow path that it took was research agent gave the answer, the writer agent then formatted it, and critique agent, when it evaluated it, it gave the evaluation more than 8 or a score more than or equal to 8, and you got the final response. So no loop, the conditional loop didn't occur, didn't initiated. So no conditional loop get initiated. It's jumping directly and giving you the final response. Perfect. Now, what we have to understand here, see, the critical part is that this is a multi-agent system. This is a multi-agent system, and we implemented it in LangGraph. And from here, you can use any large language model, any architecture, any workflow, the way you want, the way you envision, the way you want to design to create what? To create a multi-agent system in LangGraph. And that is the real power of LangGraph. In real life, we all know a researcher does the research, a writer formats the output, a subject matter expert evaluates, a reviewer improves. And that is a division of intelligence. That is a division of work. And that is exactly what we implemented here. And now, with this simple code, you can also implement any complex workflow with multiple agent. Okay. So please use this code. With that, I'll pause here. We'll see you in the next session. Thank you. Have a nice day.